So for this problem, we need to find equations of the tangent lines to the curve y equals 2 over 1 minus 3x at the points with x coordinates 0 and -1. So step 1, use the given formula to find the y coordinates from the given x coordinates. So when x equals 0, we take our formula, y equals 2 over 1 minus 3x, and we're going to plug in 0 for x. And this will turn to 2 over 1 minus 0, which gives us 2 over 1, which is 2. So our x coordinate will be 0, 2 for the first coordinate. And then when x equals -1, take our equation again, and we'll plug in -1 for x this time. So -1 equals 2 over 1 plus 3, because -3 times -1 is positive, which turns to 2 over 4, which turns to 1/2. So our second coordinate is now -1, 1/2. So in step 2, we need to find an equation that will determine the slope of the line using the difference quotient when the limit of h approaches 0. So here we'll use the difference quotient of f of x plus h minus f of x over h. So when the limit of h approaches 0, we're going to take our y formula and plug it in for f of x plus h and minus f of x. So f of x equals 2 over 1 minus 3x. So here, for the first one, we're going to put 2 over 1 minus 3, and for x, we're going to plug in x plus h. So we plug in x plus h, minus f of x, which is just 2 over 1 minus 3x, that's just our formula that we were given, and we'll put this all over h. Now to get rid of the denominators on the bottom, we have to multiply both top and bottom by these denominators. So that's what we're going to do. So we have 1 minus 3 x plus h times 1 minus 3x over 1 minus 3 x plus h times 1 minus 3x. Now as the limit of h approaches 0, here this 1 minus 3 x plus h is going to cancel out, and that's going to leave us as 1 minus 3x times 2. So we're going to have 2 times 1 minus 3x. And then this is going to be minus, and then here we have this 1 minus 3x, so these will cancel out, and we'll have to multiply these. So minus 2 times 1 minus 3, x plus h. And then we're going to put the whole thing over h times both of those. So h times 1 minus 3, x plus h, times 1 minus 3x. Factoring out, this will leave us with 2 times -3x is minus 6x, minus 2 times 1 is 2, -2 times -3, actually we'll just FOIL out the center right here, so this will be 1 minus 3x minus 3h. Put that over h times 1 minus 3 x plus h times 1 minus 3x. And now we'll factor out this middle part, so we'll get, as the limit of h approaches 0, we get 2 minus 6x minus 2, 2 times 1, -2 times -3x is plus 6x, and then we'll get -2 times -3h, which would be plus 6h, over h times 1 minus 3 x plus h times 1 minus 3x. Now, if you look at this, there will be things that we can cancel out now. So we have a 2 and a -2, a -6x and a positive 6x. Now this leaves us with the limit of h approaching 0 of 6h over h times 1 minus 3 x plus h times 1 minus 3x. And these h's right here will cancel out, so that leaves us a 6 over 1 minus 3 x plus h times 1 minus 3x, and we have to always write our limit of h approaching 0. And now, when we don't have to plug in our limit anymore, because now we're going to plug in 0 for h, and this will leave us with 6 over 1 minus 3 x plus 0 times 1 minus 3x, and this will equal 6 over 1 minus 3x. 3 times 0 is 0, so we're going to leave that out. times 1 minus 3x, which equals 6 over 1 minus 3x squared. And this is the equation we were trying to find with the difference quotient. So we did that. Now we're going to move to step 3. Now we're going to plug the given x coordinates into the equation that we found in step 2, which was using the difference quotient to find the slope. So the first x coordinate, when x equals 0, we use our equation of 6 over 1 minus 3x squared. Kind of messed up there, but that's okay. That's 1 minus 3x squared. Now we're going to plug in 0 again to this equation for x, which is 1 minus 3 times 0 squared, which will turn to 6 over 1 squared. It's because 1 minus 3 times 0, 3 times 0 is 0, 1 minus 0 is 1, which 6 divided by 1, because 1 squared is 1, 6 divided by 1, that gives us 6. So this is the slope when x equals 0. So now when x equals negative 1, we're going to plug in our equation once again, 1 minus 3x squared, and this will turn to 6 over 1 minus 3, plug in negative 1 for x squared, which equals 6 over 1 plus 3 squared, because negative 3 times negative 1 is plus 3. This will be 6 over 4 squared, 1 plus 3 is 4, 6 over 16, and to reduce, 2 goes into these pretty even, so 6 divided by 2 is 3, 16 divided by 2 is 8, and this gives us 3/8, and this will be our slope for our second equation. So now lastly, in step 4, we use the given x coordinates, our determined y coordinates, and the slopes we found for each. Use y equals mx plus b to solve for the equations of the tangent lines to the curve. So here, we're going to use our first coordinate that we found. So we know x was 0, we found that y was 2 when x is 0. So using y equals mx plus b, this will turn to, now we're going to plug in 2 for y. We're going to plug in our slope, which was 6, that's what we found in the last part. So when x is 0, our slope was 6, times x, which is 0, plus b, because here we want to solve for b. That's the point of this. So now this turns to 2 equals 0, 6 times 0 is 0, plus b, and then b just equals 2. Obviously that 0 goes away. So now our equation in standard form will be y equals 6 for the slope, x plus 2. And this is the slope formula for the tangent line of the first coordinate. So that's our answer for the first one. Now for the second one, when negative 1, 1/2, our second coordinate, we're going to use the same equation, y equals mx plus b, and this time we'll plug in half for y. That's what this turns to. Half equals our slope that we found was 3/8. We're going to plug in negative 1 for x, and then we're going to solve for b. So this will turn to 1/2 equals negative 1 times 3/8 is negative 3/8 plus b. So we need to get rid of the 3/8 on the right side to put it on the left side. That way we can solve for b. But in order to do that, we have to find common denominator. So for 1 over 2, it looks like 2 to get to 8 is times 4, so we'll multiply the top and bottom by 4, and that'll give us a common denominator of 8, so we can add those fractions together and get rid of that on the right side. So it looks 2 times 4 will be 8, 1 times 4 is 4, equals negative 3/8 plus b. Now we'll add 3/8 to the left side. What you do to one side, you got to do the other, that way they cancel out. So these cancel out, and this turns to 4 plus 3 is 7 over 8 equals b. And writing this in standard form, this leaves us with y equals 3/8, which was our slope, x plus 7/8. And that is the equation, second equation, for the slope of the tangent line to the curve.